In analytics use cases, you don't need raw events all the time. You just want aggregates. For instance, let's say you want daily user stats or session durations. So instead of running group by queries over billions of rows again and again, what you can do in ClickHouse is store aggregate states and keep merging them incrementally. That's what AggregatingMergeTree does. And let's take a quick example so you can understand what's going on under the hood. We're going to create a hits table with a user ID and a duration. It's a regular merge tree. We don't care about partition or sorting key in this case. And we're going to insert 5 rows. We're going to have a couple of rows for the user ID 1, a couple of rows for the user ID 2, and a couple of rows for the user ID 3. Now we want to aggregate session duration by user ID. So we can use an aggregating merge tree like this, in which we're gonna have for each user ID the session duration. And we're gonna use this aggregate function that it's gonna sum the session duration, okay? So if we insert into this table, we're gonna insert everything we have in the hits table, and we're gonna calculate some states for each user ID. So now let's see what has happened under the hood. If we look at the partitions of the hits table, what we have is one single partition. We are not partitioning, but we have 5 rows. And if we take a look at the parts in our aggregating merge tree, what we have is again one single part, but with 3 rows, because we had 3 user IDs and we've aggregated by them. So if we run a query over the session stats table, we need to use this aggregate function to merge all the session durations. In this case, it's already merged and it's going to give us the results. We have 3 user IDs and this is the duration for each one, the session duration for each one. But if we keep inserting data, let's do 3 inserts more in the session stats table. Now if we go and look to the parts, we're going to have 4 parts, every one with 3 rows. These are intermediate aggregate states that when we do a query using SummingMerge, they are going to be aggregated, okay? And we're gonna have again one result for each user ID. Whenever a merge happens, we're gonna force it, optimize table final. Remember, you don't do this manually, this is done by ClickHouse automatically. So now all the parts have been merged, and we're gonna have in the parts table is we have the session duration aggregated by the 3 user IDs we have in the table. So the trick is that ClickHouse doesn't store the final sum, but it stores the internal state. And whenever it does a merge, then it merges to a new state that can be merged with other states that happen whenever you insert in that table. So the different states are combined both on merge or at query time. One important thing you have to take into account with aggregating merge trees is the sorting key is what defines how data is going to be aggregated. So you define your sorting key to be user ID. It means for each user ID, we're going to have the session duration. Okay. If we had more dimension columns, we should add them to the sorting key. So this is what you have to take into account when working with aggregating merge trees. They are good to optimize group by queries with pre-aggregated data. So basically ClickHouse stores intermediate states that can be merged incrementally both at query time on when the merge background process happens. You need to use the aggregate function type, which is the ones that tells ClickHouse to create those intermediate states, and then you can merge at query time. And this is very good for rollups, aggregations, dashboards, any analytical query in which you need to do a group by and you don't want to do it at query time, okay? There are a bunch of aggregate function types. We will see them when we talk about materialized views, because usually when you use this engine, you have materialized view in the middle. If you just want to do some calculation over your metrics, then it's recommended to use the SummingMergeTree. In this case, we're gonna summarize views per date and user ID. This works very similar to the AggregatingMergeTree, but with some differences. So we are not specifying any aggregate function in this case because it's implicit in the SummingMergeTree, and the order by key, the sorting key, is going to be the group key. So let's create this table, and now we're going to insert, for instance, 3 rows. We're going to have user ID 1 and 1 with a couple of views, and user ID 2 with 5 views, okay? So if we now do a regular query over this table, we're going to see it's already aggregated. So we had 2 different rows for user ID 1, but it's already aggregated, okay? Now, if we insert again, let's insert a couple of more times. Now we're gonna see is we're gonna have this not aggregated, because remember, ClickHouse, every time you run an insert, it creates parts depending on the partition key, and they are merged in the background. So this eventually will be merged by date and user ID, which is the sorting key we defined in here. But you can force it at query time, and the way to do it is by running a regular aggregation, okay? So you can do sum of views by user ID and date and group by all. And that's how you merge at query time, just by running the regular aggregation, okay? The important part about this is that you can use the SummingMergeTree when you want to do this specific operation, which is summing numeric columns. It's going to give you very fast merges compared to AggregatingMergeTree. It works out of the box. You don't have to use state and merge functions, aggregate function types, etc. But if you want to do like more complex analytics, unique calculations, average, other type of aggregation functions, you will use AggregatingMergeTree. If you just want simple counters and summarized metrics, then go with SummingMergeTree.